then I will put this. So today we are discussing like two things, maybe three things. So one thing, we will discuss with Kiran microarchitectural problems in system Verilog homework. And second, there is a person who came to my first meeting in a Hacker Dojo. So his name is Jimmy Lemon, and he is working in AMD. And we discussed with him a very interesting idea how to make a open lane tutorial. So let me a little bit elaborate on this before we start with Kiran. Just a second. This is Google Docs. So first of all, so let me talk a little bit about like overall current plan. So first of all, I want to restart seminars in Hacker Dojo, like at the very end of the month, maybe like April 27. But before I do this, and like seminars in Hacker Dojo will be purely to prepare people to port to like clean up current examples on different FPGA boards in order to make a wide show and tell FPGA event for like a wider audience. So what I want to do is that like maybe after like I don't know a couple of months or something, or like 3 months, we can make an event where like a few participants in previous seminars, like 5 or 6 people, will be there with like 30 different FPGA boards, and we'll show different FPGA board and make uh, uh, and like show different tool chains. Or Vladimir Churyukin is on the call, and actually he just ported examples to several new FPGA toolchains. So he will be obviously one of those presenters. But like generally, I want to make a wide seminar with a presentation by multiple people, and each person will show FPGA board and what you can do with this, including sound processing, sound generation, and graphics for both VHD for both VGA and HDMI. And so like we show like several different tool chains and usage and so on. And like different person will make some part of this presentation. But in order to do this event, we need to clean up examples with different FPGA boards, and multiple people should prepare their slide and their speech. And basically, the goal of such seminars is to prepare such presenters. George Zavala, so what do you think about it, about this idea?
Well, it could be very good idea to be back again in life. It's a lot of things to be learned about all these techniques and technologies. And the hardest part, I am trying to create something like my participation, and I am having a lot of questions that I need to even myself organized because even my questions are not very well clear for me.
Yeah,
In
yeah.
that sense,
So like basically the task to clean up examples and make presentation, it's like of course it's not like something micro architecturally sophisticated, but this is a necessary step to like establish a base for like any other things. And we can combine it by with showing it to like wider audience. And another thing what I want to do, I want to go again to Silicon Valley Computer Programming Club monthly meeting, like even the last month, and they want to go there before and just to learn how they are doing it. And maybe I will go to couple more of such meetings, uh, just to see what like other people are doing. Or there is a programming microcontroller. So who is the person who is doing programming microcontroller meeting? So
is
maybe.
Robert. That one is Robert,
Uh,
the guy that is doing the robots and all these things on the electronic lab.
so but for how but what did he do before? So did you like attend his meetings? So how does he organize it?
I never been in any of his meetings. I know that he has been doing a lot with Arduino kind of things and try to do more hands-on experiments and working with that more than a conference presentation. Is more really a get together and the people find how to build something with the Arduino's boards.
Okay, so mostly focus on Arduino, right?
Yep.
Okay, yeah. Maybe I can also talk to him and see how we can make a demo with FPGA and microcontroller combination to like add some like twist and like a wider audience, because maybe he can present such demo as well. Because like technically, uh, for instance, he can output some data using UART or uh, to like connect microcontroller and FPGA board, and then to use it as a sort of like IO extension or something even more interesting. Uh, yeah, so we can talk about it. Yeah, but let me go to this meeting on April 20th and then see uh, how I should schedule for maybe like April 28th. So and then maybe make it monthly at the last Sunday of each month. So like April 28th and then like end of May, end of June and so on. So maybe something like this. Yeah. Okay. Now going back to proposal from Jimmy. So let's see his proposal. So for those of you who don't know, let me put eFabless. Uh, so there is such joint project between Google and eFabless. It's to make open source uh, way of manufacture uh, chips for startups, universities, and research. And people can use open lane, like open design tools. And let's see. So they have a website where they put uh, cheap designs from different people, and they also propose uh, a platform. Uh, Wait, what is this platform name? I already forgot. But they have a platform where you have like liter risk 5 like housekeeping CPU, and you put your user logic. So you have a template to build your own chip. And this all can be done with like open source tools. And this is very significant because uh, uh, buying like commercial tool is not an option for very many people. And I'm talking about Synopsys design compiler, IC compiler, Cadence Genus, and Cadence Innovus. Because like all those tools, they cost like hundred thousands and more. So like a Synopsys IC compiler license for one engineering seat like 20 years ago was $300,000, and now most engineering teams, like a team in like large company or a team in a startup, they simply pay uh, to Synopsys uh, something like $1 million a year subscription, or make like group and Intel, I think, was making deals for like tens of $1 million to use in large engineering team. And this is not an option for like just the research people. Also, Synopsys and Cadence, they make deals with universities, and it's possible to use these tools either through Synopsys and Cadence educational programs, or via places like Euro Practice. It's an organization in Europe where university can pay some fee like $3,000 a year, and simply use these tools for free. But this is still not a very good option for a kind of independent person who want to just experiment with ASIC design tools. So this option of using OpenLane is a very valuable one. And during the last 5 years, OpenLane became much more stable. So uh, Jimmy Lemon is a person who is working in AMD. So he is like seasoned physical design engineer working with professional tools, and I am discussing with him making open source tutorial with OpenLane, and here is a document with his proposal what can be discussed. And if any of you have some input about this proposal, please send the mail and the proposal. So like I shared link in mailing list. So please read it and send what you want to be included. Uh, so and there are many already tutorials for both OpenLane and for all RTL to GDS to flow. Um, there are also classes. So there was a class in University of California, Santa Cruz extension in Silicon Valley, and I went to this class like 7 or 8 years ago. And Charles Danchik, who was a former Intel process engineer, uh, he was teaching that class, but and teaching very well. But certainly uh, Charles Danchik was not a physical design engineer. He was initially process engineer, and he did this for Synopsys commercial tools. So we can make something like this, but with a like actual working physical design engineer who like has experience like as a design engineer and not a software engineer like me or process engineer like Charles Danchik, so which can make such introductory tutorial more solid, like based on like solid experience base. Okay, so this is the second thing. Now, uh, what what else? What else I wanted to discuss? Okay, so now let's talk just for a few moments with Vladimir Churyukin, who is on the call, and Vladimir said that he recently ported to some new tool chains, and after Vladimir, so let's let's talk with Kiran and discuss microarchitecture. But let's start with Vladimir because it's like shorter. So, Vladimir, what can you tell about your new boards?
Yeah, so I so I tried to port. Let me show the board, by the way. There is a Chinese producer called Pango Micro. Let me turn off blurring video. Wait a second. Yep. There is a board like this, produced by Lynx. Yeah, and this Chinese producer, it has its own toolchain called.
Wait, but Aliens produced boards with both
Yeah.
Altair
So
Cycles
it's
and
not a
Cyrus,
Lynx.
this is
A
something
Lynx
different.
is Lynx is producer of the board, right?
Yeah,
But
what is
it
this
uses
FPGA?
the FPGA from Pango Micro. Yeah, so if you can
Pango
see or
Micro.
not, there is a chip Pango right
Yeah.
here.
So how different is this FPGA than like other FPGAs?
So the toolchain is pretty similar, I would say. The only difference is like all documentation is in Chinese. It's not that easy to read. Boards are pretty cheap. So for what they have, they're like pretty much like cost similar as Govin boards. Yeah, so I haven't integrated the toolchain into our scripts because I only have a Windows version of Pango Design Suite for now. So I ran it in a virtual machine. So I was able to just basically create a project for one of our labs and test how it works in like regular UI. But it would be pretty easy to integrate. I just need to get like they have Linux version. I couldn't download it because you have to register on that Chinese website, and it's I I could not. So maybe I need some help from somebody who speaks Chinese to do that.
Yeah, but maybe when we resume meetings in Hacker Dojo, then there are some Chinese speaking people, so we can talk with
Yeah,
them.
I will do that. Maybe next week we'll ask somebody to help. So I can share my screen just to show the tool if
Yeah,
you're
sure.
interested.
Yeah.
Let me open Zoom on. Wait a second, I need to open Zoom on another computer. Okay. So I'm not sure how well it will work because I will need to share my screen and it is in a virtual machine. So I'm not sure how it will all work in Linux. But I'll try. Yes, I'll share screen. Show machine. Yeah, apparently it's working. Yeah, so this is Pango Design Suite. Yeah, there is this like sources tab. This is, I don't know how to call it, like, yeah, it's report summary. Like all the reports are here. And here is the flow. Right, so compile, synthesize, device map, place and route, generate bit stream. Yeah, so I took the first lab, which is like the most simple one. It just calculates XOR between two different buttons. Yeah, one thing is this whatever compiler they use, it doesn't fully support, I think, System Verilog, because this syntax, for example, so this lab doesn't use slow clock module, so it just commented it out. But
just a second. So, but does it support at least some syntax Verilog, or does it support only Verilog 2001?
Yeah, it supports System Verilog, but some syntax weirdly, like this one, for example, it was not supported for some reason. I don't know why.
This syntax I know very well that some tools do not support this syntax.
Yeah.
This
is this one is not supported.
This is something. Yes, this is something which like this particular problem I do know.
Okay. Yeah. So yeah, just run the flow, like either one particular step or like until some step, run from the first one. For example, I just compile stuff. And you can check the reports. So there are a bunch of tools here, like power calculator, power planner, debugger. They have two different compilers. I think they use Simplify Pro, and they use something different. But for this one, you need a separate license, and I don't have it. So I used another one, which is I'm not sure how it's called. It's in project settings.
Are they using Simplify Pro?
There is an option, yes, to use it as a synthesis tool. So they use either ADS or Simplify Pro. But for
and what is ADS?
I have no idea.
I never saw it. Yes.
Yeah, but I know that this one works without a separate license, and Simplify Pro requires separate license.
Yeah.
Okay, so
Simplify Pro is like I was using it in the 90s. It was a very good tool, but it is not cheap.
yeah.
I mean, it is not free, but it's not only it's not free, it's also not cheap. So it's so but do they list any information about Simplify Pro?
Yeah, they list, but it's all in Chinese, unfortunately. Yeah.
Interesting. It would be interesting to dig how much they charge and whether evaluation or education license is available and so on. Okay, fine. Yeah.
Yeah, so you can edit constraints, including like mapping of pins and stuff like that. Device, yeah, device, IO. Yeah, so you can map pins here. You can group them. So there is a documentation. Again, it is in Chinese, but it is pretty clear, like how to map pins, at least from this documentation. So I mapped them, and then you like once this flow is done, you generated the bit stream, then you go to configuration. It is running already. Yeah, this one. This one, you basically need to connect to the server, which is already running. And then you can just program. You can just program the board. Oops, board was not running. Yep. Programming is super fast. And as I can see, like this one is working.
And this tool is very similar to Quartus or something like that.
It
mean,
has the same function, but it does look somewhat different.
Yeah, they are all similar because they have same steps. They have all the same steps. Like it differs in how it all looks like and how it is implemented, but by function it's all similar. Yeah, so they have.
Sorry. There is any source of how to learn Quartus or all these tools, because they have so many things and I get confused. But you really need to learn about that, about them.
Yeah, so this flow is pretty much the same for all of them, right? So in some tools you have a simulation step also included. They have their own simulators. In these tools, you don't have simulation here, but other than that, like everything like compile, synthesize, device map, place and route, you can see in other tools as well.
Yeah, but actually, like our goal, like one of goal of like activity of like people on the call is to make a set of scripts. So we were using scripts which actually make learning about details of Quartus unnecessary. So basically, what we are saying is that we need to learn details of tool chains like this Quartus or this tool chain to make this learning for like most of people are necessary. So like other students just like press one button, run the script, and then script figures out, okay, this is for this FPGA board, I use another tool chain and then knows about all the details of the tool chain. And the student just need to know name of a board, and he should just know where to get like timing analysis like about his design, but such thing as synthesis and uploading design to FPGA board should be automated. And like now
Yeah,
we are
so
looking
this
into how this all placed inside FPGA. This step uh, uh, is usually not used by like professional people who simply generate text reports. Um, and for a beginner student, he can certainly look inside such diagram to just get a feeling that code is translated into hardware, but for him it shouldn't be necessary to learn all the options of Quartus or this tool.
yeah, so
This is
there are
kind of
command
it.
line variations of this toolchain. There is this PDS and there's this PDS shell. It basically it accepts the project file name and work directory, and it runs like all the same steps in command line basically. But you need to prepare the project file for that. To prepare the project file, and the second tool is to run the like to upload the bitstream into the device. So this one generates the bitstream. And there is this one. It uploads its shell version of the programmer. It uploads the bitstream. But you need to prepare this project file, which looks like something like written in Lisp. And there is no documentation on this format, of course. So you just, I mean, you need to add a bunch of files to the project and some other files that generate as intermediate intermediate steps, like I don't know what that is, like DB output and stuff like that. Yeah, but this stuff probably can be kept as is, as like as it is generated by default. You just need to change the input files for our purposes, at least. Yeah, so I think it would be pretty simple to integrate with our scripts. Just we'll need to generate this part. Yeah, it generates a lot of stuff, a lot of logs, reports, stuff like that. Duration log, hashtag, server log, device map log.
So eventually we also need to write a script which extracts timing and the area information from log of all tool chains we support, like Xilinx, Altera, Govin, Lattice, then Efinix, and this one. What is
Yeah, so there is
and the Pango, yeah, and open lens, so like everything should be extracted for all designs. And then we should run scripts to get the full picture of capacity and uh, uh, of FPGA on each board and the timing. So what is the maximum clock frequency and so on.
mhm. Yeah, so there's timing report, and probably you can extract something, but
This
I'm
is
not
actually
sure
a
how
good.
exactly
This
yet.
is a good project for some like student to just create a script which is compatible for all different tool chains. By doing this, student can also uh, learn and compare different tool chains.
That's kind of research and a bit of like reverse engineering work because you don't know how exactly it is generated, in what format. You need to.
But this must be documented somewhere because both Xilinx and Altera they do allow people to write tickle scripts to work with command line tools. They they do not force people to use GUI.
Mhm. Yeah, this one also supports tickle, by the way.
Okay.
Yeah,
So can you do
yeah. So
everything using
you
tickle
have this
scripts?
console. You have this console. You can like tickle console. You can enter commands here,
So can
and
you
you.
do everything using tickle commands?
I'm not sure. I'm not sure if I can, but it should be possible, I think. But PDS shell. I'm not sure if it can run something. Yeah, specify the CMD action to run. So probably if you like dash run, probably runs something.
Okay. So basically, once we resume Hacker Dojo events, so maybe you will bring all those boards on, like, let's say, like April 27, and then demonstrate and we see like how many how many examples we can run on those boards, and just to have some more hands-on demo with those boards, right?
April 27th, by the way, I probably
No,
will
no,
be
20,
will be
28, not 27, 28, 28. So are you available at the time or not?
yeah, let me check because I have some event on that weekend specifically.
Uh, this is fine. I mean, we can do it later. It's not crucial.
Mhm. Okay. Yeah, so
Okay.
my next goal would be to just get Linux version of this one, so I do not run it in a virtual machine, or maybe just try to set it up on under Windows as well, because we need to support Windows, right?
Yeah, we do. Okay, so if this is all that we let Kiran to present what he is doing,
Mhm.
right? Yeah. Okay. So Kiran, so you can now talk about what you did with this homework exercises. So you can share the screen.
Mhm. Yes, sure. Uh, so is everyone able to hear me and see the screen?
Yeah.
Okay. So my goal was to complete task 29. So that is add validity signal for three variants: global stall, skid buffer, now performance pipeline register. So the first task was, yeah. So this is the first task that I implemented. So the task here was working with, yeah. So for Formula One. So this is basically Formula One, and I needed to implement global stall and all the three variants. So the code to this design is something here. So the way that I implemented was, uh, yeah. So this is the slice register, and this is where I implement uh, the buffers. Let it be global
Ah, okay.
stall, let it be skid buffer. Yes.
Yeah.
Okay. So so you can see the I square root module is right here, and I have the I square root slice register. All the inputs that are going to this component is right here, and this is where I implement whatever all the three variants. And the reason I implement two variants here is because I have two inputs, COX and COY. Basically, you don't have to do this. There is another method that let me show that as well. Uh, yeah, it will start. So you can implement something like this. So I
Wait a
have
second. What file you're showing? Because I don't see.
this one, the
Oh,
last file.
okay, yeah.
Yeah, you can implement this way also.
Oh, wait. Last one. Because I see many columns and they don't see your cursor moving. So maybe you
Oh,
can highlight something.
yeah, you can see the cursor.
Yeah,
Let
I
me
can
show
see
you this.
cursor,
Yeah.
but yeah. Ah, okay. So this one. Okay, okay.
Yeah,
This one.
that's better. So you can implement it this way also, where I implement I square root the whole the slice register for all three variants. The reason I changed this design was because I wanted to implement Formula 2. When I tried to implement Formula 2, the method that I'm showing you now was much more feasible. So let me close this design and let's just look
Oh,
at, yeah.
one immediately like important point. So we
Mhm.
need to change I valid I ready into up valid, so like upstream valid, upstream ready, put like up underscore and down underscore, because
Uh-huh.
here it is very confusing when we have output port I ready, because
Hmm.
like I means input, so
Yes.
this should not be like input output, this should be upstream downstream.
Okay.
Yeah, so
Okay.
let's make this change everywhere, because
Mhm.
I do know this is like source of confusion.
Okay.
Or you can make it even like UND, but UND is not very clear for education examples, so it's better to make up and down.
Okay.
Yeah.
Yeah, I mean, I did not know the degree of freedom that I had to do. That's the reason I have few variants. So
Yeah.
that's one of the reason I requested this meeting so that we
Yeah.
can discuss how exactly we can implement this, or how exactly you want to implement this design.
Mhm.
So so this is where I implement the buffers. Let it be global stall or skid buffer, or
Yeah.
whichever buffer that you want to implement. So the
This
one
is
way
fine.
is I can have a header file appear, and I can change which implementation that I want, whether I want a global stall or a skid buffer or a half performance buffer. and that'll take care of what implementation that I'll be using here.
Yeah.
And you can see the skid buffer, that is the design right here. So the skid buffer is right here. And similarly, let me show you the global stall as well. So this is global stall,
Yeah.
and this is the half performance buffers.
Yeah.
The reason why I created this as a separate file or a component is because when you try to implement Formula 2, it becomes much more easier. The coding is much more easier. You just have to call the components and implement, and that takes care of it. It becomes easy to implement the design. So we can go ahead and run this implementation right now. So once we
For
run, yeah,
before I forgot, there is some like minor inconsistency if you go back to the code. So let me just catch you
okay.
like some do some like nitpicking. So in
Hmm.
half performance module, first of all, uh, you put input without logic, and then you put input logic, and like basically in rest of like in rest of code, like for example, we like assume that input is uh, uh, you don't need additional logic keyword with the input port, because
Yeah.
with the input logic is by default. But
Hmm.
for output you do need logic, because you assign to this output inside always block. And when you
Yeah.
assign inside always block, you always need logic, so which is a fine.
Yeah. Yeah.
Uh,
I mean, I
now,
can change that. That's
yeah,
fine
yeah.
because I use Emacs to automatically assign inputs and outputs for me, so I don't take care of all that. So when I generated this design in Emacs for automatic, so I forgot to do all of that, and I can do
Yeah,
that.
so
Hmm.
let's just clean that, because the less text we have, it's like easier for people to read.
Hmm.
Uh, so now, yeah. So one thing is like up down, then remove unnecessary logic. Uh, yeah, and another thing is that I was using like buffer like defiance, and you also like use buffer define, but uh, one alternative to it, instead of using define, we can create a module called pipeline register, like pipe reg or something, and we can make this module parameterizable with a parameter, and then use inside generate. And generally, generate is a more clean way
Hmm.
to do things, because uh, defines, they can introduce some like problems, because defines a global and generate is local. So you can also think about creating a version without this buffer, and just create a wrapper module called pipebridge, or wrapper module called buffer, and in this wrapper module to create a generate, and then if um, like if we generate a global stall or something, then do something. Yeah, you can just consider it. I mean, like
Okay.
buffer using define is okay, but
Hmm.
we may like just create two versions and compare them and see, and run it through many people and ask them what is easier to read.
Okay.
Yeah, so we
Something
cannot
like this
generate
is,
in there something like this. Yeah, but for
yeah, yeah.
pipeline register. So like now like consider consider generate instead of define.
Hmm. Yeah, sure. I did
Yeah.
think of this, but you know, for the
Okay.
purposes of finishing
Yeah.
up, I know that. Yeah, I can change that as well. That'll be much more easier because from the
Uh,
top module, I can just
yeah.
change the numbers. Mm.
Maybe also it is useful if you can create microarchitecture diagrams in like Lucid Spark or Lucid Chart or
Okay.
Visio, like this one. Um, so there are like many diagramming tools. I usually use Lucid Spark, but if you create in like another tool, we can convert it to Lucid Spark.
Okay.
So it is up to you. So which such drawing diagramming tool do you use?
I mean, I don't use a lot of drawing diagrams because I like to draw. I use my iPad to get everything done. Uh, so I
So
can use Lucid Sparks, as you said.
yeah,
And
Lucid Sparks is good because you can draw it like even on a telephone. So like you see,
okay.
I have like I got this like
Mm-hmm.
Samsung telephone
Mm-hmm.
like as a part of Samsung team, and it has a stylus.
Mm-hmm.
And with the stylus, I can actually draw microarchitectural diagram
Mm-hmm.
on like on Lucid Spark, and it works like even on a telephone.
Okay.
So yeah, and with like on like iPad as well. So with like stylus, it's more precise on, but on telephones without stylus with finger, it's less convenient.
Mm-hmm.
But uh, like uh, like a Pixel phone is a nice phone, but it doesn't have stylus. Um,
Yeah, I usually use
like
iPad,
on computer.
so that should do the work if that's the case.
Yeah, yeah. So you just and the Lucid Spark in my opinion is better than Lucid Chart. So both you can draw both using Lucid Spark or Lucid Chart,
Mm-hmm.
but Spark for me is a little bit better because it's uh, uh, Lucid Spark was created after Lucid Chart, and it can do everything Lucid Chart can do, but it has also collaboration, and the way to do free drawing is better than a Lucid Spark. Than like Lucid Chart. So like Lucid Chart is considered more uh, like more high end than Lucid Spark, but in my impression, they have similar feature, and Lucid Spark is a little bit better designed.
Mm-hmm. Okay.
So you can try. Yeah, and like I'm using actually paid license. I think that free license is also uh, functional, but with free, it has some limits on how many features you can create, something like this. And, and also think it has limits on conversion, but you can explore both. Um, yeah, and if free version is not sufficient, you can explore Draw AI or just buy paid version, which is like uh, I don't know, like $7 or $10 a month.
Okay.
But for me, it's a good investment because most convenient microarchitecture drawing tool for me. Yeah.
Mm-hmm. Okay.
In principle, some people like even draw such diagrams in like Google Slides
Mm-hmm.
or in like a Microsoft
PowerPoint.
PowerPoint, but
Mm-hmm.
it's less convenient than the Lucid Spark.
Okay.
Yeah, and like Microsoft Visio, which is used by many companies inside, uh, from my perspective, is not nice because
Mm-hmm.
like some lines are jumping and there is like a lot of like legacy. It's a Microsoft product with a like long history. First there was Visio company and then Microsoft, and together it's just less nice to draw than Lucid Spark. Yeah.
Mm-hmm.
Okay. Yeah. So let's make diagrams for all these designs and make some slides so that you can
Okay.
actually present this all as a coherent presentation
Mm-hmm.
together together with a reference to digital design books and like other places. Yeah. Okay. So let's
Mm-hmm.
continue.
Yeah. So, so we have the design right here.
Mhm.
You can see. Uh, I think the better one, we could just see the script. Let me just change that.
Yeah.
Let me. Test bench. Yeah, I think that should do the job. Okay. Yeah. So we can see Formula One is pass. So right now what I'm doing is I am just trying to simulate Formula One, and for Formula One, what I'm trying to use is a global stall.
Yeah.
So, and I've made some changes to the test bench as well. So I've not uploaded all these, the updated
Okay.
version. On GitHub, you just have Formula One,
Change.
which is the previous design.
Yeah.
So
So can it show changes in a test bench? So what is the change in test bench?
yeah. So in the test bench, let me make that big. So this is the test bench.
Yeah. You are just randomly generate radius.
Yes.
Okay. Yeah.
Yeah.
Okay. Yeah. This is good.
So basically, this is the part that I changed right from here. So you can
Okay.
see my arg valid is 1 and res ready is 1. Then I
Yeah.
change my arg valid for some time, and then this one, the pipeline is inactive because my arg valid is 1 and res ready is not ready. The output is not ready to receive, and here the output is ready to receive, but the input is not valid. And if there's
Yeah.
any data in the pipeline, that's going to be drained out. And this is where I generate random values, and then I drain the pipeline, flush the pipeline again right here. And this is where I generate random values. And I can change this just for the purpose of verification. I made sure all the inputs are generated between 0 and 1, just so that it's easy for me to verify. If at all I need to look at the waveforms.
Yeah.
So
This is
this is,
this makes sense. Yeah. This makes sense. If like argument is ready and valid, then you change data. Yeah. This is how like it should be done. Yeah.
yeah.
Like I
So
would
so this is,
modify spacing here to make it more consistent, but it's okay
hmm
right now. Yeah. So we need to like make all spacing uniform
yeah,
for
I, I'll,
this
I'll, I
build
can do
test.
that.
Yeah.
Yeah. That'll be done. Even this one, it's not required to specify as one, arg ready and arg val,
Yeah, yeah. You
all of
should put
that.
here if arg ready and arg valid because this equal one is just like extra text.
Yeah, extra work. Yeah.
And actually,
So,
I do see that like many students write it in this way, but usually in like in industry we are trying to find less text
less.
because
Hmm.
uh, better like if valid and ready, then
Hmm.
you change data. Yeah.
Yeah, yeah, that can be done. I think.
Oh, one also another thing in
Mhm.
some your module you wrote like if reset and something, and there are some linked tools which don't like it.
Okay.
They want to write if reset, then code for reset, and then if not something like even if code is the same. So no, it's not here. It's in
Okay.
different place. It
Different
is a
one. Okay.
different, yeah, a different one. Like I just saw it. Uh,
Mhm.
they just want to write if reset. Ah, wait, it's not here. I think it was different module.
Uh,
Maybe it was even my module. I'm not sure. But if
okay.
it's my module, like I need to change it. So
Mhm.
we should put if reset without ending or o-ring reset with something else, because there are some tools like linters which want to have uh, if reset separate from like any other logic. Yeah.
Okay. So
Okay. Yeah.
basically, what you're trying to sell is this is how it should be done. So I do not need to
Yeah.
have any other
Like if
condition with
reset.
reset.
Yeah. No.
Yeah,
No. Any other condition with reset. Yeah.
yeah, yeah. I,
Because
I think that's
if you put any other conditions, then this may be problem with both linters and with treating by synthesis of asynchronous or synchronous reset. I already don't
mhm.
remember all the problems it causes, but just for safety, it's better to put it in separate blocks of logic. Yeah.
Yeah,
Okay.
yeah.
That's
Mostly,
that's
this
good.
is what I practice. So it should be something like this. If it's not, I can
Yeah.
go
Yeah.
ahead and
Yeah.
make changes
This is
to it.
fine. Yeah.
Yeah.
Yeah, this is fine.
And so, yeah, that's Formula One.
Oh,
And
like
yeah.
also like another nitpicking here, you
Mhm.
mixed all valid one B0 with all valid
This
uh,
one?
zero. No, no. Here in a half performance buffer,
Uh-huh.
line 22 and line 26. So they use different constants. You
Oh,
can
yeah.
use either one. So like sometimes,
Yeah, yeah.
so usually in like industrial code, if it's one bit, like we use one B0, but
Hmm.
in some code I use simply uh, like tick zero, but this just has to be used consistently. You use either first one or second one, and not like mix it. Sometimes first one and sometimes a second one. Like usually it's not like harmful, but for educational examples, we should enforce consistency everywhere.
Yeah, yeah.
Yeah. Yeah. Okay. Yeah. So let's continue next.
Yeah. So half performance register is pretty much okay. Then what we can do is, oh, it's right here. I don't need this. I don't need this as well for now. And even skid buffer. So basically, what I verified or referred is this textbook, as you mentioned. So my global stall was something related to this. So if there's ready, you use the marks, and this is basically I ready is O ready. So this is the reference that I use for global stall, and this is the reference that I use for skid buffer.
Yeah. This is fine.
So you can verify skid buffer as well. Let me open 4, 3, pretty much do the same. Yeah. So Formula One, again, it's a pass. So for skid buffer as well, I'm able to uh, see the correct output. And similarly, we can verify half performance buffer. We can do that. And let's just close the waveform, and you can see for all of the design, I am able to see the output which is passed, which was pretty simple, the first one. Uh, One thing to consider is for Formula 2. Formula 2 is where I wanted to just have a discussion. Yeah, so this is the one. So for Formula 2, these are just using registers. So the way that I implemented the registers is if if my square root module is implemented using a global stall, my shift register will be implemented with a global stall. And
Yeah.
similarly,
Yeah.
this
We
is,
can do it. Yeah.
yeah. So, and similarly, these two registers as well. I would be implementing with a global stall or with half performance buffers or with skid buffers. So that's the idea that I've implemented. So this is one of the questions that I wanted to ask you, if that's okay, or is there any other way that you
Yeah,
wanted
you
to
can
implement?
you can do it, but generally we can just tell to students that you can do it this way and you can like demonstrate it this way, but it is better to use here FIFO because
Hmm.
if you just put every stage as skid buffer, we just
Yeah.
use two times more flops than if you use FIFO.
Yes.
So this is just a wasteful way of doing things.
Yeah.
Um,
I think that's the
so
next task, right?
we can show them. Yeah, we can show them. Ah, no. Next task is different. Next task is
Oh, okay.
different.
So
Next task
FIFO. Oh,
is
okay.
a use FIFO after pipeline
Pipeline.
without like
Okay.
after
Okay.
pipeline
Mm-hmm.
without uh, uh, without the back pressure. So let
Okay.
me let me show you what I'm talking about. Yes, this is like
Mm-hmm.
next task, and this is what I also expect from you
Mm-hmm.
to do.
Yeah, I thought that
So
was the next task. So I was. This is the
yeah,
next task
yeah,
that you're talking
yeah.
about, right?
But
Yeah.
I'm talking about that you simply put FIFO here inside. So you're using FIFO instead of shift register. But
Mm-hmm.
in a case with back pressure, FIFO here is better because you can um, like propagate the back pressure by using signals full and empty.
Empty.
So so basically, oh wait, just a second. Let me think about it a little bit. Uh, mm, so you need to yeah, you can propagate back pressure by simply putting FIFO here
Mm-hmm.
because at the maximum, uh, if you don't have ready at the end, you simply don't need to pop from FIFO. So you pop from FIFO only when you have both valid and ready.
Mm-hmm.
You see? So
Yes.
for FIFO you don't need to have um like double number of flops. You simply pop from FIFO when you have valid and ready.
Mm-hmm.
Yeah, and that's it.
Okay. Yeah.
Yeah,
So
so
I thought this
for
was the
FIFO
next part of the.
it's
Yeah.
easier to do. Yeah, yeah.
Yeah, I
So
thought this
you
was
can
the
just
next part of the task. Yeah.
but it's still a good idea to create this using skid buffers as well, because you can show them that look, you can do this with skid buffers, but it's not a good idea because you waste two times more flops.
Yes. Yeah. That's one
And
of the reason I had not updated it. Yeah.
then we use files. Yeah, well, but we need to
Yeah.
show them and just put with a kind of addition to names,
Mm-hmm.
like not a good idea. Put comments.
Mm-hmm.
This is not a good idea. That you can do it, but this
Yeah.
is not a good idea.
Yeah. Or else you can compare, the
Yeah,
area, the
you
time,
can
and
compare
hour.
area. Yeah, and then like
That'd be a
you can
good.
create script to run it with open lane and just show that like look, this works functionally, but it's not a good idea from the area and the power
Power. Yes.
standpoint.
Yeah. Yeah. So if that's the case, yeah, I can go ahead and implement that. But yeah, I have completed that with the registers, whatever the registers that I was using, whether it's global buffer, global stall, or half performance, or skid buffer. So let me go ahead and show that.
Okay.
And one is, yeah. So the way that I've implemented that is right here. So I have the square root module, then I have the shift register with valid ready, uh, and this is the buffer again. This buffer flip-flop 1 is this one.
Yeah. So just to
Yeah,
have timing
consistency, timing,
for
yes.
like addition, yeah,
Yes,
for addition here,
yeah.
for an
And
adder.
yes, and for flip-flop 2 is right here.
Okay. So can you show
Flip-flop
me
2,
your
yes.
shift inside of your shift register with valid
Yeah.
ready?
So let me shift register with valid ready. Is
Yeah,
this
yeah,
the
yeah.
one? Yeah, this is the one. So this is what I did. So this is again is going to be pretty easy. So whatever that I'll be using, what out of the three options, global or skid or off performance, again, that's going to choose, and this will take care of it. That's the reason I separated all of those buffers for Formula One as well, just so
Yeah,
this part becomes easy. And your
sure.
coding is pretty simple. All that I have to do is call that buffer, send the inputs and outputs, that'll take care of it. Here again, call my shift register with valid ready, send inputs and outputs, that'll take care of everything.
Okay.
So that's what I've implemented. And here again, I tried to make the pipeline depth global as well. I don't know whether I have the freedom to do that. I wanted to ask you again. So we can send, again, from the top module, we can send the number of stages that we want, and based on that, you can calculate the depth for the registers and whatnot. You can do that instead of having pipelines specified in each of the pipeline in the I square root module. We can
Ah,
have
yeah,
that
sure,
declared globally. So I
sure.
can do that as well if that's required.
Yes, this is fine. But because we everywhere specify parameter with lower case, it's better for consistency to also use here
Okay,
lower case.
so
So put here not like PST because um, uh,
I
usually
mean that's just a random, yeah.
like all engineering groups like usually like many engineering groups like both like in MIPS, Imagination and many other companies use a lot of three-letter suffixes or things, but
Hmm.
like for VLD, RDY, and so on. But but here but usually it's used for a bunch of like similar elements. But
Hmm.
here for like pipeline stage is not a good idea to use this like PST because it, this name is not like obvious for a reader. So it's better to simply put a local param pipeline stage and
Hmm.
then just put it everywhere. Yeah, or put like I use n pipe stages
Hmm.
in like a SQRT. So it's better to put here like something like uh, uh, ISQRT underscore n pipe stages to make sure that we refer to number of pipeline stages
Okay.
in ISQRT.
Hmm.
Yeah, so just put like ISQRT underscore n pipe stages.
Okay.
Yeah, instead of PST. Yeah.
Yeah,
Okay.
that can be done. Yeah, so this was one of the questions that I had, because using uh, registers was not a good
And
idea.
by the way,
Hmm.
this is better to do not a local param, but make a parameter of formula module.
Hmm. Yes,
Yeah,
I
because
will
like a
do that. Yeah.
local param with the whole formula, it means that user can instantiate the whole formula and then like experiment what happened with different number of pipeline stages.
Hmm. Yeah, I'll make it global so that right from the test bench,
Yeah,
not from this test bench, from
right. It should be propagated from the
yeah,
top test
from the
bench. Yeah.
top module to
Yeah.
the lowest. Yeah.
Okay.
So somewhere here, instead of like the way we specify pipe, we can specify the number of stages, and we can also specify the buffers that we want to use. I can instantiate 0, 1, and 2, and I can send that here, and that will go again. And instead of using buffer, it'll instantiate uh, whichever modules that we want. So right
Yeah,
from
yeah,
one
we can
place.
start it. We can start it right from here. Yeah, we can
Hmm.
make it parameter of a formula TB
Okay.
because this is the same attribute as a formula number and pipe. We also specify
Hmm.
number of pipeline stages here. Yeah.
Yes. Yeah. So,
Okay.
so yeah, this was one of the main concerns that I had because shift register was not a good idea to use. But since uh, I had some time, spare time, so I went ahead and implemented this. It was just
Yeah.
connecting registers. So that's one of the questions that I had. Uh, the second one is for FSM. So since FSM is, as you said, it's not pipeline. So the way that I have designed right now is whenever I'm going to have another input coming here and that's going to be register ready. When that is ready, I'm going to that will select, tell me that my arg valid is ready to receive all the inputs, and that will receive all of the inputs A, B, and C. And arg ready will not go high until I get valid from all of these three outputs, and then I will, based on my res ready, my arg ready will be high. So that is how I have designed for now. But I wanted to know how exactly
Yeah.
do you.
I will review it, but the thing is that
So because
so
this is what I saw. Yeah.
yeah, we can uh, first of all uh, yeah, this like arg valid. Yeah, first of all, we don't need to have individual valid for A, B, and C in this example.
Yeah. I don't have that.
Yeah, we can have only one valid for like A, B, and C, and
Yes.
it should be ready only after after FSM finish everything
Finishes.
and is ready to like accept new accept a new pair of ABC.
Mm-hmm.
And yeah, so we should give it ready when we are ready to like accept a new pair, and we shouldn't accept new pair unless we also send the output result to the downstream block.
Yes. Yeah.
Yeah,
So
so
that's.
this logic also should be there. So we should have ready from downstream block, and if downstream block is not ready to accept, we should not be able to start a new FSM, because if once we
Mm-hmm.
start a new FSM, then uh, then then it has to finish, and it will like override this result. Um, Also,
Uh-huh.
there is a alternative. We can also freeze FSM,
Mm-hmm.
that even if FSM starts,
Mm-hmm.
it will not go to the end. Uh, like it will not go to the end unless we send our result to the downstream. So
Yes.
here you can have actually multiple different options. You can
Yeah.
either not accept input, or you can freeze FSM,
Professor. That's right.
and like it's like up to you. But you can implement different variants and just show that with this variant we can save like clock cycle, and
Mm-hmm. Yeah.
so
I mean
with like
that's.
different number of variants we can save, and with the global stall you can simply stall FSM state,
Mm-hmm.
so you can just freeze FSM state. Yeah,
Mm-hmm. Yeah.
so
I
like
mean.
instead of writing down if reset state is equal, send a else state is equal next state, you can write in down that else if uh, like uh, downstream ready, then state is equal next state. So if downstream is not ready, we can just freeze state.
Okay.
I'm talking about line 171.
Mm-hmm.
Yeah.
Right here. Yeah.
So you can just put
instead of going to
stall
this.
there. You can just stall writing into state.
Mm-hmm. Yeah, but right now what I've done is I've just stalled the output. So I have the output and it's going to hold the output as long as res ready is high. And if res
Uh-huh.
ready is high, then I will send the output and then I'll move on to accept new states and new inputs. And in state A, it is going to receive new inputs and then it will go on to the next state.
Yeah, you can do it this way. You
Mm-hmm.
can do it this way, like which is fine.
Mm-hmm.
So you will just stay in that state until you go into initial state, and you put upstream ready.
Mm-hmm.
So you can put upstream ready only.
For state A.
Uh, yeah,
Yeah, that's real.
like only this. Oh, okay, fine. Yeah,
Yeah.
it works. Yeah.
Yeah. So this
Okay.
is what if there's another way that you want me to implement, or if there's any other better way,
No,
you
this is
let
fine.
me
So
know.
like as long as you don't introduce any like idle states,
No.
it should be fine. Yeah,
Yeah. Okay.
it should be fine. So you put here. You put here into like temporary once you accept it. Yes, alternative is that
I mean, I
you
don't have to use
yeah,
temporary. This was for another logic, because that
yeah,
state will still be holding the inputs. The inputs
uh-huh,
won't change because the arg ready won't be ready. So I can
uh-huh.
directly have B instead of temp.
Yeah, yeah. You
So,
can you can be in temp. Yeah, it's
yeah,
better to clean it little bit because
yeah.
temp may just confuse reader. Reader may think that if you're using temp, you want to latch this value into
Mm-hmm.
a flop to use another value next clock cycle. But since you are not going to use like another value on another clock cycle, uh, you don't need this temp really. Yeah,
Yeah, I think that was for a different logic. So I can clean up the code
yeah.
for
Let's
that.
clean up with those steps. Yeah,
Yeah.
this is fine. Okay. So you
Mm-hmm.
can clean it, and I will do like then review everything.
Okay.
Yeah, and prepare a presentation. One
Mm-hmm.
one thing actually I met recently. Cliff Cummings, this like famous author of
Mm-hmm.
papers.
Yeah, I
Actually,
do
I
work
was
with him.
talking with him that like
Mm-hmm.
maybe he can put some paper. So like if you want, you can like I will write him some like email, like
Mm-hmm.
like outlining this, and then I may propose him so that three of us actually can write paper with him if he is agreeable to such idea.
Yeah, sure.
This actually can be like a good hit because this area is not covered well, and Cliff
Mm-hmm.
Cummings is the number one author in this area. So let's
Mm-hmm.
uh, let's try. Maybe this can work. Yeah.
Mm-hmm.
In which case, I will write to him something short,
Mm-hmm.
and like I will ask you to work with him to create some like elaborate text, and then we publish it with all three our name if Cliff Cummings can agree to it.
Mm-hmm.
Yeah.
Sure.
So we can try it. Yeah. Okay.
Mm-hmm.
So this is okay. So like anything else?
Yeah. So that was one of two questions. One was
This,
the shift register, and one was the FSM. Uh, yeah, I can go ahead and add FIFOs as well. And
yeah.
in the presentation, probably comparing the area, the time, or the energy, especially the power consumption using
Yeah.
uh, FIFOs and shift registers. That will be a good analogy to
So
understanding
which
where FIFOs can be used and where shift registers can be used. Yeah.
yeah. So which dynamic power analysis tool do you have access to?
I mean, I use Vivado, yeah,
Well,
because I have the
But
license.
does Vivado allow to analyze power,
Uh, yeah,
the dynamic
you
power
have a power report
specifically?
for it. I'm not sure
But
how.
but
Yeah.
but you have power report for synthesis, and
Yes.
to like analyze power, what you need to do is that to like analyze the dynamic power,
Mm-hmm.
you can do it only if you run certain tests,
Okay.
because you need to first extract information during synthesis, then you need to run a simulation test on gate level design in
Mm-hmm.
case of ASIC, or like on synthesized FPGA design, and
Mm-hmm.
then see switching activity during
Mm-hmm.
this. So when you do this for ASIC, you use a tool um, like Synopsys Prime Time PX, so PTPX,
Mm-hmm.
where you first synthesize and then you extract parasitics, and then you run PTPX with the original test bench, and
Mm-hmm.
then it generates a waveform file with all the switching activity, and then you combine waveform file together with of parasitic extraction data, and then you come up with dynamic power.
Okay.
But with the synthesis alone, you cannot do this.
Okay.
So,
Mm-hmm.
so if you have at your university access to a prime time PX or to Cadence Joule, this is probably the best way to do it. If you
Okay.
don't have, you can contact Cadence with their educational programs, or
Mhm.
we can ask Cliff Cummings to do it for us. So, like even
I mean,
uh, like unfortunately in Samsung I cannot use it outside of
mhm,
Cadence, like of Samsung project. So we need to
mhm.
find some like legal way of estimating this, like without enclosed company resources. Yeah, so like either at your school or through Cliff Cummings, so using open source tool if such open source tool available.
Okay. I have access only to Vivado completely. Cadence is there, but I don't have access to Cadence because mine is completely digital field. So I have a complete version of Vivado, but not Cadence.
So
I need to
not
get
not
access to
not
Cadence, so Cadence
Yeah,
won't be.
let's first discuss with Cliff Cummings to see
Okay.
even if this is even if this is even an option, and if this
Okay.
is an option, then we can ask this from him.
Mm-hmm.
Yeah.
Yeah. Sure.
And then, like if Cliff Cummings is not an option, I know manager of Cadence Education and Program, so we can shoot him an email and ask that maybe we can do it this way.
Mm-hmm. Sure.
Yeah. Okay.
Yeah. Yeah, those are the only two questions that I had. I will
Okay.
go ahead and clean the code. For now, I'll update everything that I've shown you on GitHub so that you can verify, at least for the code cleanup. I will get the FIFO done and I will update you with the FIFO as well.
Sure. Yeah.
Yeah.
Yeah. Okay. Okay. So I think this is all with you for today. So does anybody else have any questions? So you have George, okay, Max Kudino, Marcus. Yeah. So I think we discussed everything you wanted to discuss for today. So talk to you next time. So next time we'll have some more material probably. Yeah.
Thank you.
Okay. So thank you everybody. Okay.
Mm.
Bye bye everybody.
Bye now.
Thank you. Bye bye.
Bye bye.